Hello everyone, I hope you are all well and healthy. Still with me Party Roseate. In this session I will explain about how to start kiln operations in a cement factory. In the previous video session, we explained how to do a heating up kiln. The heating up kiln has been done and is ready to start up the kiln operation. Let's start to operate the kiln with a temperature condition that is ready for the feeding kiln. The temperature at the kiln inlet is already 715 degrees Celsius. Then the sintering zone is 1020 degrees Celsius. Then we first start the transport for feeding material. We prepare the transport for line 1 and line 2 to start feeding. And we set each bait 50 tons per hour. We click raw meal batching, and we start the group. Then return to the kiln display. After starting group feeding, we observe the material that enters the preheater system. The feeding material has entered and the top preheater temperature immediately drops. We add the pull to 20%. So that we can add O2 and add fuel, we add 2 tons of coal per hour. The first time the heat consumption when the feed is inserted is definitely high. After adding the feed little by little it will go down. O2 is very low at 1.2%, it is expected that at the time of operation, O2 will be approximately 1.8% to 2.4% and CO below 0.15%. The kiln inlet temperature is still low, then the sintering zone temperature is below 1200 degrees Celsius, the top preheater temperature is below 300 degrees Celsius. We increase the ID fan kiln filter speed from 25% to 30%, with the addition of the ID fan kiln filter O2 speed increases and the top preheater temperature also goes up. We observe that the temperature in the kiln inlet is still low, so the decarbonization is still 2%, because the temperature of the calciner is still around 700 degrees Celsius. We increase the pull speed of the ID fan preheater to 30% for line 1 and line 2, to 30%, so that O2 increases and can add fuel to the calciner. We set the use of coal fuel in the calciner to be around 1 ton per hour, so that the degree of calcination can increase. The burner calciner is directed to the rise duct and the 1 to TAD is closed at 0% because the secondary air temperature is still low. Then we start using this button. Just started, then we observe the operating conditions. We observe that the O2 and CO in the kiln inlet are still safe. We increase the fuel in the calciner to 2 tons per hour, and the degree of calcination has started to rise. It has started to rise and free lime is still high. If this is too long it can flush heavily and cause the kiln to stop. We must try to improve the quality of the clinker first according to the established standards. Then increase the feed so that production capacity can increase. Because the top preheater temperature is already high, we increase the feed to 20 tons per hour for line 1 and line 2. The top preheater temperature must be kept below 400 degrees Celsius for 4 levels of cyclone, and for 5 levels of cyclones kept below 350 degrees Celsius. We increase the speed of the ID fan kiln filter, because the O2 is low, and we will increase the speed of the ID fan preheater. The O2 in the top preheater is around 2%. And the O2 in the kiln inlet is around 4%. All start groups are green, meaning all operating parameters are in normal condition and there is no alarm. Free lime has started to fall below 3%, the calciner temperature is still below 850 degrees Celsius, we have to increase the fuel in the calciner to 3 tons per hour. The secondary temperature is still low and we don't dare open the TAD damper yet, we increase the fuel again by 1 ton to 3 tons per hour. This is low O2 in the top preheater, we add 5% speed ID fan preheater for each line first. O2 in the kiln inlet is still sufficient and the sintering zone temperature is around 1500 degrees Celsius, we don't need to add fuel to the main burner. Decarbonization is still low, we have to increase the temperature of the calciner, because the O2 in the kiln inlet is high. We try to open the 20% TAD damper, so that it can increase the O2 in the top preheater and lower the O2 slightly at the kiln inlet. O2 in the top preheater rose to 2.4% and O2 in the kiln inlet 4%, because the secondary temperature had started to rise, we increased the TAD damper opening to 40%. The temperature in the sintering zone rose very high at 1600 degrees Celsius, then the O2 in the kiln inlet was 1.9%, we added air from the cooling fan, because the opening of the ID fan cooler damper was only 4%. First, we increased the grate speed by 10% each for grate 1, grate 2 and grate 3. So that the clinker temperature is not too high, the cooling fan damper must also be increased, especially the grate 1 cooling fan, each of which we increased to 50% for cooling fans 1, 2, and 3. Then for the grate 2 cooling fan, each increased to 40%, then for the grate 3 cooling fan, it was increased to 40% respectively. So that the clinker temperature can drop below 150 degrees Celsius. With the addition of fan cooling air, the draft of the kiln hood approaches positive and the sintering zone temperature rises above 1600 degrees Celsius and the kiln shell temperature approaches 400 degrees Celsius. First we have to increase the speed of the kiln, because it was too late to increase the speed, then add feed from 70 tons to 90 tons per hour for line 1 and line 2. Then the material from cyclone 4 is partially added to TAD by 20%, because the temperature from TAD is dropping, we increase the fuel consumption in the calciner from 3 tons to 4 tons per hour, then part of the fuel is added to TAD by 20%. This changes that occur in the kiln very quickly. The sintering zone temperature is high and the kiln shell temperature is also above 400 degrees Celsius. This was due to a drastic change in the cooler system earlier. The positive draft of the kiln hood affects the shape of the flame, and affects the temperature of the sintering zone. Here we can see that the sintering zone temperature is above 1600 degrees Celsius, but at the kiln inlet it is still below 900 degrees Celsius. This means that the heat is retained in the kiln, and there is less hot gas going to the kiln inlet or to the preheater. This can be seen in the cooler. There is an alarm, let's see, yes, it turns out that the high clinker temperature is above 400 degrees Celsius. We have to secure it first so that the kiln doesn't stop, by increasing the cooling fan air, especially in grate 3, each of us increasing it to 60%. The kiln hood draft changed because there was an addition of cooling fan air in the grate cooler 3, for the cooler system it is safe, but the sintering zone temperature is still above 1600 degrees Celsius and the free lime is 1.5%. The feeding is 180 tons per hour, the O2 in the top preheater is still sufficient, and this degree of calcination is still low. We increased the fuel consumption in the calciner to 4 tons per hour. Then we observe the temperature between the TAD outlet and the riser duct must be balanced. Some of the feed material from line 2 has been entered into the TAD and that from line 1 is still going to the riser duct. We observe that the temperature difference in the top preheater between line 1 and line 2 is almost the same. Then we add 1 ton of material to the calciner to make 5 tons per hour. Next, we partially separate the feed material from line 1 or 20% is put into TAD. Then we open the TAD damper to 50% so that we can increase O2 in the top preheater and can add fuel to the calciner. We observe the process and O2 in the top preheater and O2 in the kiln inlet is still low, so we increased the speed ID fan preheater. Previously we added the opening speed ID fan kiln filter. Then we observe the O2 in the top preheater starts to increase and the O2 in the kiln inlet is still 2.5%, and the free lime is still 1.8%, the kiln speed is still 1.8 rpm, with kiln feed of 180 tons per hour, decarbonization is still low. We increase the fuel consumption in the calciner from 5 tons to 6 tons per hour. We observe the process. The outlet temperature of TAD is 850 degrees and the riser duct outlet is 834 degrees Celsius. We see the condition of the cooler. The clinker temperature of 116 degrees Celsius is still quite good, then the grate speed is still low. We add cooling fan air consumption for grate 2 from 40% to 60% respectively, before we add kiln speed and kiln feed. So that later it will not focus on the cooler but focus on the main control panel of the kiln. Then we increase the grate speed for grate 3 from 60% to 70%, then for grate 2 from 50% to 60% and for grate 1 from 30% to 40%. For the clinker temperature it is still safe at 120 degrees Celsius, then we return to the display kiln. There is an alarm in the sintering zone and draft kiln hood. Every time we add cooling air there is a change in the temperature of the sintering zone, meaning that the combustion heat is focused in the kiln, and the kiln shell temperature also rises. We increase the feed each to 100 tons per hour. Free lime is still 1.6%, then we increase the kiln speed to 2 rpm, because the kiln shell temperature is quite high. We expect the shell kiln temperature to drop and the sintering zone temperature to drop slightly. For the O2 kiln the inlet is still sufficient, then the temperature in the calciner is 850 degrees Celsius, and decarbonization has started to rise above 50%. We slightly increase the TAD damper opening to 60%, the O2 in the kiln inlet is low, the sintering zone temperature and the kiln shell temperature are still high. We increase the speed of the ID fan preheater each to 50%, so that the O2 at the top of the preheater increases and can increase the fuel in the calciner and can increase the feed. We increase the fuel consumption in the calciner from 6 tons to 7 tons per hour. Next, we observe all operating parameters, O2 and CO in the top preheater, then O2 and CO in the inlet kiln. Then with the increase in temperature in the calciner, decarbonization also increases above 50%. We must maintain a temperature balance in the calciner between the TAD outlet and the riser duct outlet, so that decarbonization can rise above 85%. We increase the fuel consumption in the calciner again, so that the temperature in the calciner is above 850 degrees Celsius and decarbonization begins to rise above 60%. Because the O2 in the top preheater is still sufficient, we will increase the fuel consumption from 7 tons to 8 tons per hour. We increase the fuel in the calciner by 1 ton to 9 tons per hour. Then we increase the opening of the TAD damper from 60% to 80%. With the addition of the TAD damper opening, the impact is that the O2 in the kiln inlet must decrease. Then we increase the speed of the ID fan kiln filter to 70%, then we can increase the speed of the ID fan preheater line 1 and line 2 to 70%. We do it gradually until the kiln operation reaches optimal. We increase the combustion of fuel in the calciner to 10 tons per hour. Then we increase the feed for kiln line 1 to 120 tons per hour and line 2 to 120 tons per hour. Next we increase the kiln speed to 2.4 rpm. Because the speed of the kiln is increased, we must increase the speed grate cooler and add cooling air. We increase the damper opening of the grate 1 cooling fan each to from 50% to 70%. Then for the grate 2 cooling fan, we also increase each from 60% to 70%. Next we return to the monitor kiln. The temperature of the sintering zone and shell kiln is high, but the temperature at the kiln inlet is low, and the decarbonization has started to rise above 80%. Because the temperature at the TAD outlet is 900 degrees Celsius, we separate the material from cyclone for line 2 to TAD from 20% to 30%. Then we open the TAD damper from 80% to 100%. Because the temperature of the sintering zone is high, we increase the kiln feed for each line from 120 tons to 140 tons per hour. Because we add more fuel consumption in the calciner to 12 tons per hour. We observe the temperature in the calciner and the degree of calcination. Because the temperature in the calciner drops, we increase the fuel consumption again to 14 tons per hour. Here the O2 in the kiln inlet is low, we add the air intake from the ID fan preheater, we increase the speed ID fan preheater again to 70% for line 1 and line 2. With the increase in O2, then we add more fuel consumption in the calciner so that the decarbonization increases. Next, we add the use of cooling air in the cooler system. We add a grate 1 cooling fan, each of which is increased by 10% to 80%. Then we also increase the rate 2 cooling fan to 80%. O2 in the kiln inlet increased slightly, and the temperature of the sintering zone was normal. Then the kiln inlet temperature began to rise slightly. Then the decarbonization can reach more than 90%. Because the temperature in the calciner is 880 degrees Celsius, we increase the kiln speed from 2.4 to 2.6 rpm. Then we separate the material from cyclone for line 2 to TAD from 30% to 40%. We observe the whole process, all in normal conditions, and decarbonization has reached 93%. Due to the high preheater temperature, we increased the kiln feed by 10 tons, line 1 to 150 tons per hour and line 2 to 150 tons per hour. We separate the calciner fuel that goes to TAD from 20% to 30%, and we increase our fuel consumption from 15 tons to 16 tons per hour. Then the material from Cyclone 4 line 1 is separated towards the TAD from 30% to 40%. So that the temperature between the TAD outlet and the calciner outlet is balanced. Because the TAD outlet temperature is still high, we separate the material from Cyclone 4 line 2 which goes to TAD to 50%, we separate the material gradually. for line 1 and line 2 so that there is no drastic change in calciner temperature. This decarbonization has already reached 96%. We increased the feed material, for line 1 and line 2 each from 10 tons to 160 tons per hour. Next we increased the speed ID fan preheater. O2 in the top preheater and O2 in the kiln inlet has increased, but free lime 3%. Because the temperature of the sintering zone tends to decrease, we increased the fuel in the main burner by half a ton to 11.5 tons per hour. We have to improve the quality of the clinker first, then we can add feeding. We increased the fuel in the main burner again to 12.5 tons per hour. It is hoped that the free lime will decrease. By adding 1 ton of fuel in the main burner, the O2 in the kiln inlet goes down. Then we increase the speed ID fan kiln filter. We add the speed ID fan preheater line 1 and line 2 each 5%. So we can add fuel to the calciner. We increase the fuel in the calciner to 17 tons per hour. Decarbonization is still above 90% and currently 94%. But free lime is still above 3%. We try to change the draft of the kiln hood from -0.8 to -0.6 millibar. It is expected that the sintering zone temperature will increase and the free lime will decrease. Free lime is gradually decreasing. We try to lower the draft of the kiln hood again to -0.4 millibar. Because the O2 in the inlet kiln is still sufficient, we increase the fuel in the main burner to 13 tons per hour. We increase the kiln speed to 2.8 rpm. It is hoped that the temperature of the sintering zone will increase and the free lime will decrease. The secondary temperature has not been able to rise above 850 degrees Celsius, with the addition of a speed kiln. It is expected to increase the bed material above the grate and the secondary temperature can rise. We increased the kiln speed from 2.8 rpm to 3.0 rpm. With the increase in the kiln speed, the secondary temperature gradually begins to rise, and the free lime also gradually decreases. The O2 in the kiln inlet is still above 2%, but it is high decarbonization up to 98%. So we can increase the material feed. We increase the material feed to 170 tons per hour in each line. We add fuel in the calciner to 18 per hour. Then we add 10 tons of feed material each to 180 tons per hour line 1 and line 2, or a total of 360 tons per hour. Because the temperature at the calciner and the TAD outlet is not balanced, the material from cyclone 4 line 1 is separated into TAD to 50%. Let's see the parameters in the cooler system. Don't let the clinker temperature rise. For the cooling air for grate 3 we add each to 80%. We return to the main monitor display. This kiln hood draft is approaching positive, because earlier we added cooling air from the grate 3 cooling fan. After we reset all the conditions of the kiln operating parameters are safe, meaning there are no alarms, both in the preheater, kiln and cooler system. Decarbonization is still 94%. Kiln material feed is 360 tons per hour, but free lime is still 2.8%. Secondary temperature is above 800 degrees Celsius, then the fuel consumption in the main burner is 13 tons per hour, and the fuel consumption in the calciner is 18 tons per hour. This operating condition can still be optimized up to a clinker production capacity of 5,500 tons per day or around 380 tons per hour of kiln feed. Because the ID fan preheater speed is still 85%, and we can still add more fuel to improve the quality of the clinker product and increase the clinker production capacity. Alright, we will finish this session here first. Then in the next session we will explain how to optimize kiln operation and operate coal mill in one monitor display. Thank you for watching this video. I hope it's useful, and don't forget to subscribe, like and comment, and share it with friends who need it. See you in the next video.